Questions 21 through 25 on the 2008 Grade 8 Gauss Math Contest. In the diagram, the object is made up of 7 1 by 1 by 2 solids. What is the total surface area of the object? All right, so we have to figure out what is exposed and what is hidden. First, let's just concentrate on the 2 by 1 shapes, so the ones that look something like this, right? And then we will concentrate on the ones that look like that, the 1 by 1. So here we go. First, 1 by 1 probably is the easier one. We got 1, 2, 3, 4, 5, 6, 7, and then we have an additional 7 on the other side, right? Back here that we can't see. So that's 7 plus 7, so 14 of these guys. Okay. Now let's look at the 2 by 1s. This is 2 by 1, and this is 1 by 1. 2 by 1, okay, 1 here, 2, 3, 4, 5, 6, 7. Then there's going to be 1 there, 8, 9, 10, 1 below here, 1 here, 1 below here, 1 below here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of those. All right, so that's basically all there is to this. Now we have to figure out the total surface area. So surface area, 14 times the 2 by 1, and each of those is 2 by 1. And then 14 of the 1 by 1s, and each of those is 1 by 1. So this is 14 times 2 plus 14 times 1, which is 42. And therefore that is A. 21 is A. A 3 by 3 grid is filled with the digits 1, 2, and 3 so that each number appears once in each row and column. 2 examples are that and that. How many different ways are there of filling the grid? All right, so let's start off with just the top row, okay? If the top row is 1, 2, 3, what will be the next row? Well, the next row can be 2, 3, 1. Or if the top row is 1, 2, 3, the next row can be 3, 1, 2. And then the bottom row, the third row, we have no choice. It has to match in a way that each column has only 1, 2, 3. So there's only one way of doing that for each of these, like this. So that's it. So for 1, 2, 3, as our first row, there was 2 possible ways of arranging this. All right? And similarly, if we change the first row to say 1, 3, 2, it will also result in just 2 possible ways of arranging them. It'll be 2, 1, 3, 3, 2, 1, right? But then the third row, we're stuck where there's only one way of doing that for each of them. 3, 2, 1, and then 2, 1, 3. All right? So in a very similar way, for each of these top rows, there's 2 possible ways of making this grid. So the top row can also be 2, 1, 3, right? The top row could also be 2, 3, 1. And the final 2 arrangements for the top row are 3, 1, 2, and 3, 2, 1. And for each of those, there will be 2 ways of making the grid. So you see what's happening here? So in total, we got 2, 2, 2, 2, 2, 2, and that is a total of 12. So number 22, the answer is B. And if you'd like, you can write out all the grids, but that's kind of time-consuming, especially on a math contest. In the diagram, each circle is divided into 2 equal areas, and O is the center of the larger circle. The area of the larger circle is 64 pi. The total area of the shaded regions is... Area of the shaded regions is the big circle, which is pi big R squared divided by 2, plus the small circle, pi small r squared divided by 2. All we have to do now is figure out r, big R, and small r. Well, this clue will help us figure out big R pretty quickly. Pi big R squared is 64 pi. So that means r squared is 64, and therefore r is equal to 8. Now, if you look at this diagram carefully, you'll notice that if I draw a line from O to the end like that, that represents the radius, right? It represents big R. But you'll clearly see that big R is equal to 2 times small r, right? Because that red line I just drew represents the radius of the large circle, but it represents the diameter of the small circle. So that's why we get this relationship. And we know that big R is 8, so that means R is equal to 4. Small r, that is. So going back to our formula, we got pi big R, which is 8 squared over 2, plus pi small r, which is 4 squared over 2. 64 over 2 is 32 pi. 4 squared is 16 divided by 2, which is 8 pi. And this is 40 pi when you add them together. So number 23, the answer is D. The sum of all the digits of the integers from 98 to 101 is 9 plus 8 plus 991000101, which is 38. The sum of all the digits of the integers from 1 to 2008 is... So we've got a lot of work to do in this question, but let's take it one step at a time, systematically. First, let's just look at 1 to 10. That's going to be 1, 2, 3, all the way up until 9, right? And if you do that, if you add them up, it's just 9 times 10 divided by 2, which is 45. All right? So that's the first one. Now let's look at 10 to 11. It's 10, 11, 12, all the way up until 19, right? Now we're adding, not the numbers, we're adding the digits. Okay, so be careful. First, let's just add up the units digits. That's just 1 to 9. 1 to 9 is always 45. Then you're adding up the tens digits, which in this case are all ones. 1, 1, 1, 1, like that. And how many of them are there? Well, there's 10 of them. So that will be 45 plus 10. Okay? Similarly, if you go from, this was 10 to 19, if you go from 20 to 29, let's see what the pattern is. It'll be 20, 21, 22, all the way up until 29. Again, if you look at just the units digits, that will add up to 45. And if you look at the tens digits, those are all 2s, and there's 10 of them, so it would be 2 times 10, which is 20. Okay? And very similar, you can keep going until we get to 90, 90 to 99. That's going to be 90, 91, 92, all the way until 99. If you add up the ones digits, it's 45. If you add up the tens digits, it'll be 10 times 9, which is 90. So these guys, if you add them all up, how many 45s do we have? Well, we have 9 of them. So 9 times 45. And then 10 plus 20 plus all the way up until 90 is really just 10 times 45. Because if you factor out a 10, it's like 1 plus 2 plus 3 all the way up until 9. And therefore this is going to be 855. All right, so that takes care of that one. Now we get to the next part, which is going to be hundreds. So let's look at 100 to 109. So we got 100, we have 101, 102, all the way until 109. And then if you're adding up the digits, the units digits will give you 45, the tens digits give you nothing, and then the hundreds digits is all ones, so and there's 10 of those, so you got 10. Okay? And then we got 110 to 119. 110, 111, 112, all the way until 119. Units digits, again, give me 45. But now the tens digits give me all ones. So if I add up those, there'll be 10 of those. And then the hundreds digits are, again, just ones. So that just gives me 10. And then similarly for 120 to 129, this gives me 45 for the units digits. It gives me 20 this time for the tens digits because it's all 2s and there's 10 of them, so 2 times 10 is 20. And then for the hundreds digit, it's still 10. And then dot, 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 I'll just jump to the 190s. 190 to 199. Units digits 45. Tens digits give me 90. And the hundreds digits give me 10. So adding up all of these, I'm going to have how many 45s? Well, it looks like I'm going to have 10 of those. So 10 times 45. And then these guys in the middle, it's like adding 1 plus 2 plus 3 all the way till 9, but you have to multiply that by 10. So it's 10 times 45. And then these guys, that's pretty easy. That's just 10 times 10. So that's 10 times 10 like that. And if you add up these, that becomes 1,000. All right, so I hope you're getting the hang of this. And we continue like this. And I'll let you do, I'm obviously not going to do every single one from all the way up until 2008. So I'll just tell you what the results are. If you do 200s, right, the 200s, 2 to 299, exactly the way I did for the hundreds here, you'll get a sum of 1100, okay? No different. It'll be the same pattern, the same kind of style. Nothing changes. If I do the 300s, I will get a sum of 1200. All right? And so on and so forth. So if I do, I'll just write them side by side. 400s, and I add up all the digits, it'll be 1300, and then and so on. Now at this point, we have finished with the 900s, and we are now moving into the 1,000 plus numbers. But there is a fortunate shortcut to doing that, and I will explain as follows. If you look at this range right here, that was from 1 to 99, right? So once you pass 1,000 and you get to the range 1,000 to 1,099, all the digits, when you add them together, will be exactly the same. The only difference is that the numbers all will have a 1 before them. So it essentially is the same summation, which in this case was 900, but then you have to consider the fact that every number has a 1 in the 1,000th column, and there's 100 of them. So those 100 ones, which total 100, have to be added. So when you're adding the digits from 1,000 to 1,099, it will equal 1,000. Okay? And similarly, we can do the same thing for 1,100 to 1,199 by looking at 100 to 199. That summation was 1,000, but remember, each of these guys will have a 1 in front of it. So since there's 100 of them, there'll be 100 ones that you have to take into consideration. So you take this 1,000 and you add to it all of those ones. And if you do, you get 1,100. Okay? So that definitely helps us figure all of these out very quickly. So instead of having to go through this painful thing all over again, we can just do this very quickly by adding 100. So the 1,200s, these were the 1,100s. The 1,200s, well, let's look at the 200s. The 200s gave us a sum of 1,100. So we have to add 100 to that. So the 1,200s would give us a sum of 1,200. If you want the 1,300s, we would look at the 300s, which is right here. And the 300s had a sum of 1,200. And again, when you're looking at the 1,300s, you're looking at the same numbers, but each number will have an additional 1. So you have to take into consideration that there's 100 ones. So you add 100 to this number. So that becomes 1,300. And similarly, you just fill out the table like that. All right, so we're almost done. Our final is going to be 2000 to 2008, right? So I think I can squeeze that in here. So that's going to be 1 plus 2 all the way to 8, and that is 8 times 9 divided by 2, which is 36. And then I've got to add these 2's, and there's 8 of those, or 9 of those. So 9 times 2, which is 18. And that gives me 54. There we go. I've got all my numbers here. So let's add all these up now. I've got 45. I've got 855, 1,000. Then I've got all of these. I've got 1,000, 1,100, all of these. And finally my 54. Adding up all of those numbers, you get a grand total of 28,054. And for this question, that is answer choice E. Chantal has 2 candles, one of which was 32 centimeters longer than the other. She lit the longer one at 3 p.m. and lit the shorter one at 7 p.m. At 9 p.m., they were both the same length. The longer one was completely burned out at 10 p.m. and the shorter one completely burned out at midnight. The 2 candles burned at different rates, but constant rates. What was the sum of the original lengths of the 2 candles? So I've got candle number 1 and candle number 2. I'll let the original length of candle number 1 be x, and candle number 2, the original length, was x plus 32. So this question is telling me to find the sum of the original lengths, which will be x plus 32, which is 2x plus 32. So obviously I have to figure out the value of x. Before I begin, I'd like to explain this question a little bit as to how to approach it by giving it some numerical values. Let's say my candle is 20 centimeters long, and the rate at which it burns is 2 centimeters per hour. And I ask you, after 2 hours, what is the length of the candle? Well, it would be 20 centimeters minus 2 times the rate, which is 2, right? So that's going to be 20 minus 4, which is 16. So after 2 hours, the candle is only 16 centimeters. All right? So with a numerical example, I hope you can understand how we're going to do this. So first, before I get into the rates, let me just write out the times. So at the very beginning, we've got x and x plus 32. And the very beginning for candle number 1 is 7 p.m. The very beginning for candle number 2 is 3 p.m. All right. Now they are moving forward a little bit, and they're saying 9 p.m. for candle number 1. And they're saying that at that point, they are both the same length. All right. So I'll call it y. I don't know. I have no idea what the length is. So we'll just say y, because they're both the same length. Therefore, I can call both of them y. And then at the very end, they're saying that eventually the length becomes 0. So for candle 1, that happens when shorter one completely burned out at midnight. So 12 a.m., right? Midnight is 12 a.m. And then 0 for candle number 2, which is 10 p.m. Okay, so that's the setup, right? Okay, now we're going to get to this whole story right here. So for C1, we have x for the original length. But then after 2 hours, from 7 to 9 p.m. is 2 hours, what will be my length? Well, exactly what I did here. It will be x minus 2 times the rate. And I'll call it rate 1 for candle 1. And that is equal to y. Okay? Nothing fancy, just exactly what I did over here. And then similarly for C2, that is 6 hours, right? 3 p.m. to 9 p.m. It'll be x plus 32 minus 6 times R2, where R2 is the rate that the candle 2 burns at. All right? And then for this guy right here, 0, that is 7 to 12 is 5 hours. So it's x minus 5R1 is equal to 0. And then for this guy, it's 3 to 10, which is 7 hours. So x plus 32 minus 7r2 is equal to 0. So these are our equations that we are going to use to solve. All right, so here we go. Let's solve this now. In any order is perfectly fine. I immediately see this as being very helpful, that x is going to be equal to 5r1. Okay, and that's going to help me out, I hope. And this is what I'm going to do. Since these are both equal to y, I set them equal to each other. So we get x minus 2r1 is equal to x plus 32 minus 6r2. All right. Well, get everything in terms of x if possible. r1 I can get in terms of x. It's going to be x over 5, like that. And this is x plus 32 minus 6r2. r2, yeah, I can get in terms of x with this equation. So that's going to be, let's see here, x plus 32 is 7r2. So that means r2 is x plus 32 over 7. So x plus 32 over 7, like that. Okay, so now we just have to solve this. Multiply everything through by 35. That'll help get rid of both fractions. And if you do, you get 14x, and this will be 35x, like that, plus 1120 minus 6x plus 30x minus 960. Okay, and then if you collect like terms, you get 16x is equal to 160, and therefore x is equal to 10. There we go. So going back to our original, 2x plus 32 looks like 20 plus 32, and that is 52. So there we go. Number 25, the answer is E.